Hello guys, welcome on board. I hope you're excited to learn something new today. So just before we continue, take note that every pharmacology video on this channel is strictly according to the curriculum of medical laboratory science. So let's continue. Today we'll be looking at dose-response relationship. The drugs we take in don't just move aimlessly. They have target cells, and these drugs aim at eliciting certain responses on these cells. So the magnitude of the response of a drug in relation to the dose of that drug is known as dose-response relationship. This concept basically explains the relationship between the dose of the drugs we take in and the extent of responses it produces in our body as humans. The dose-response relationship is also called the exposure-response relationship, and this concept can be used in cases of individuals or in population. So it's an important aspect of pharmacology, and it's usually explained with the aid of dose-response curves. Why do we bother our heads about this dose-response relationship talk? Here are a few reasons. When you understand this concept of dose-response, it helps to know how safe or hazardous your drug is, and also it tells you how beneficial certain drugs and chemicals are to the body. So we said this concept is usually explained with the dose-response curves, and this curve is a graphical representation that shows how the drug's impact on the body increases or decreases as you administer more or less of this drug. So this is what the curve looks like. It's a sigmoid curve, and it's usually the response against the dose, and the dose is usually in log form. You can see the slope showing the response to various drug dosages. These curves are used for various reasons, like knowing the exact dose of drugs on different body systems. It's also used for a comparative study of drugs on different people, and these people could just be individuals or for a particular population. Also, to know the efficacy of a drug. When we talk about efficacy, it simply refers to the maximum effect an agonist can produce regardless of the dose of that drug. Think of taking a 500 mg paracetamol when you have a headache. If the paracetamol effectively makes the headache go away, it has high efficacy, but if it doesn't, it has a low efficacy. So basically, efficacy is how well a drug is able to produce the desired result. Lastly, we use these curves to know the potency of drugs. Potency simply means the ability of the drug to elicit maximum response even at a lower dose. So any drug with the ability to elicit this maximum response is called a potent drug. If I have a headache and I take drug A at 250 mg and it effectively makes the headache go away, then the next day I take drug B for a headache at 500 mg, but the headache still persists, it means drug A is more potent because it was able to elicit a maximum response even at 250 mg. And there are two types of the dose-response curve. We have the graded and Quantal dose-response curve. Curve demonstrates the effect of various doses of a drug on an individual, and it's important to note that this one has to do with individuals. And in this curve, there are two important parameters to take note of. These parameters are potency and efficacy. So in this context, we define potency as the concentration at which the drug elicits 50% of its maximal response, while efficacy is the maximal effect of a drug when all available receptors are occupied. And the graded curve is usually described by 4 parameters. We have potency, and we denote potency as EC50. Then there is the slope, and we also have the efficacy, and it's denoted as Emax. Then the threshold dose. The threshold dose is the lowest dose at which the effect of a drug is seen. So let's see what the Quantal dose-response curve demonstrates. The Quantal dose-response curve demonstrates the average effect of various doses of a drug on a population. Take note, this one has to do with population, while the graded dose has to do with individuals. So in the Quantal dose-response curve, we look out for 3 parameters, and these parameters are the effectiveness, toxicity, and lethality of the drug. The effect on this curve is either absent or present, so it's either positive or negative. So in this curve, the various parameters we mentioned earlier are denoted as the median effective dose. It's written as the ED50, while the median toxic dose is written as TD50. Then the median lethal dose is written as LD50. This dose-response relationship is basically trying to tell us that 2 different individuals might take same drug, same milligram of drug, but it's going to have different effects on them. And that's because there are 2 different systems involved here. They might not be of same height, same weight, or their body system might not be able to process that same drug the same way. So guys, that's the end of the dose-response relationship talk. Okay, so if you have questions or you're not clear on a particular aspect, you can do well to leave it in the comment section. Don't forget to like, share, subscribe, turn on the notification bell, and stay curious and keep learning. Thank you for watching.